Hi everyone, welcome to a conveyor meetup. So today we have Andrea Battaglia who will be presenting to us. He is a repeat presenter, but he always shares so many insights with us that we decided to have him back. And he's generous with his time too, to help you guys get up to speed on anything that you may need. So before I hand it over to him, just want to put out a call for anyone that's interested in sharing their insights or experience on any migration projects to Kubernetes that they think others in the community will benefit from. If you're interested or you know someone that could share with the rest of the community, just have them get in contact with me. I'll put my email in the chat so that way you can reach out. And with that said, I'll hand it over to Andrea. Andrea, it's all yours.
Thank you, Jonathan, and welcome everyone. Let me start sharing my screen. Jonathan, can you confirm you can see my screen?
I cannot see your screen yet, Andrea.
Now you should be able to see.
Yep.
Fantastic, thanks a lot. So welcome everyone again. My name is Andrea Battaglia and I'm a member of the technical partner development team for EMEA partners. And I'm specialized in cloud native app dev, digital transformation and edge computing. Today we're going to run the third of a webinar series on delivering for community, focusing today on the way you should design and work on a modernization use case. So during the first webinar, we discussed what tools can help and dramatically minimize the risks of your digital transformation analysis and project. During the webinar 2, we discussed what are the steps to design the target architecture once you have all the information you need. And today we will see how to work on the modernization in practice. Of course, we're not going to be very technical, unfortunately, because we have very limited time, but still, I will try to do my best to share with you my expertise. I will quickly talk about myself, then we will have a look at a few technical use cases you should care about and you should always keep in mind, which are the most probably use cases you can face during your digital transformation experience. And then we will do a kind of whiteboard exercise. So I will try to give you a graphical representation of what I mean during this presentation. So again, my name is Andrea Battaglia and I'm based in Italy. I work for Red Hat, for partners actually in EMEA. And I'm bringing to you my previous expertise as technical head of EMEA services for digital transformation in Red Hat. It's interesting, digital transformation is an ongoing process. And when you face digital transformation use cases and projects, you always want to have as a main goal the continuous improvement and continuous innovation for your customer use cases. And this is what we are trying to achieve in this webinar series and together with the Jonathan and the conveyor community team. Let's have a look at what use cases you can find or spot in your transformation use case. Actually, keep in mind whatever kind of actions you are taking, if you're just proving to your customer or proving to yourself and to your team and to your company that you are capable of handling all the risks coming from a digital transformation use case, or just in case you are working on one of the many use cases in a project, digital transformation project at scale, you have to be able to categorize your applications and define a blueprint for the actions to be taken based on the automated analysis. So what usually happens when you start modernizing a use case is that you have to, first of all, take care of the JDK or Java upgrades. Keep in mind that digital transformation means you are going to modernize in 1 or 2 steps very old monolithic applications that usually are not simple to analyze, just figure out, just imagine to modernize. And when you want to modernize the monolith to make it fast, or when you want to go through a monolith to microservices step process, you just have the first thing you have to do is to figure out if you can upgrade your JDK. And JDK upgrading the JDK means rationalizing the dependencies and try to figure out if all the third-party modules used by the application are compliant and supported or support the target JDK version you have in mind. Let me give you an example. Once it happened to me to get asked actually to upgrade the JDK version from Java 5 to Java 8, if I recall it correctly. And what happened was that one of the modules, the third-party modules in the Maven descriptor of the application was not supported by Java 8 and was not working actually. That module, interestingly, was not part of the runtime, so the final binary you deploy in your application server, but was part of the Maven build process. So the application, the build process was connecting to a database to download some data from a table and create out of those data, which was actually an XML descriptor, creating some plain old Java objects out of that. So transforming information. And the question was, how often should this happen? So how often your plain old Java object, so your data structure, application data structure changes? Because application data structure should be designed upfront and then get maintained as soon as you add new features to the application. And usually that shouldn't happen that much. By the way, let me share with you a little reminder. Please always split the application business logic and the application data structures of the DTOs from the official or the persistence Java objects. No? So the Java objects you use to map, for example, a database table. And so the answer was no, these objects, they may change once a year. So we split actually the process, removing that dynamic and on-demand generation and just moving those data in a separate project, splitting actually the application, the entire application repository. So please keep this in mind because this could definitely happen. The embedded framework. Now I'm reusing the image I used during the first webinar talking about Spring framework. Actually, embedded framework, they could vary. You can have different options there. And what I personally do, first of all, I try to figure out if that embedded framework could be removed. By the way, by embedded framework, I mean some hand-cooked solutions or handmade solution, not really official upstream projects or enterprise stuff. If that cannot be removed, because actually the application is completely tailored on the framework, that could happen if there are some specific technology advocates or framework advocates. It's not worth it. Or maybe let's rephrase it. The time you would spend to take out the framework is not worth the effort. And the result, and you're not definitely sure of what could be the result of your activity. Can you convert the framework? So can you move, for example, from a Spring framework or Spring Boot framework to Spring Boot on Quarkus? That could be interesting, actually. And the migration toolkit for application tool we discussed during the first webinar can definitely help, and it's very powerful, by the way. Or just in case you can't convert, so you can't move those third-party libraries to a faster and more reliable and scalable framework, can you upgrade the framework? Let me explain you why, giving you an example. Many years ago, I was working for a bank, so for a financial company, and they had this monolithic application based on Spring version 3.0, so it's probably 10 or 12 years old. So the only option to make the application itself and the modules the application was based on work properly and in a tested environment, right, was to upgrade the framework to a specific version. Now, the target application server was JBoss Application Server by Red Hat, now also known as Red Hat Enterprise Application Platform. And now, the only versions of the Spring framework certified to run smoothly and properly and supported actually on JBoss Application Server back in the days by Red Hat back in the days were 3. something and 4. something. So I had to pick up one of the two versions and made my decision based on the effort, the amount of effort to be spent to upgrade the framework to that specific version, to the target version. So be careful. Scalability. Now, when it's about monolithic application, you can definitely make them fast, but you have to take specific actions we already discussed during the in the previous webinars. You have to make sure your application integrates at scale, meaning you always have a main integration layer like a clustered AMQ environment. So the more you scale up your application in a Kubernetes-based environment, the more risky it's going to be. So please make sure your application at scale behaves exactly in the same way. And this can be done taking care of data consistency and working on the data management. So please avoid embedded caches. Please make sure you delegate data management and data consistency to your software infrastructure, meaning database engines or NoSQL engines or in-memory distributed caches, rather than having those business logics or those third-party business logic embedded into your application. That's not consistent. And last but not least, my favorite. Always think of your monolithic application as this beautiful transformer here. Now, of course, it could take some time, but you can definitely you are definitely able to figure out what are the connection between business objects, what are the components that interact with third-party software or services, for example, and whether it's possible or not to extend your business object with some REST or SOAP-based API, depending on the use case, depending on the effort and the time available, to make the application or pieces of application independent in order to be able to isolate them, and package them in I can't say micro, because microservice is a buzzword as usual. Please always keep in mind services should be atomic, isolated, consistent, and independent. The only thing you have to care about is the way they interact with each other, synchronously, asynchronously, handling connection issues or handling connection pools, right? And internally, they should be completely independent for third parties. So usually monolithic application like this big transformer you can see in the split into smaller pieces, and that's kind of important. Adhering to microservice architecture, of course, is key. As soon as you adhere to standards, you will be always able to extend your workload and scale your workload and add new features without losing too much time or without the need of a hard refactoring, and means you didn't design your workload properly beforehand. So this is all from the presentation. Please feel free to put your questions in the Q&A section. And Jonathan, please interrupt me anytime if we have any question in the proper section to give more information to our participants. So
yeah, Andrea. So we actually have one question from Jonathan Villalopez. The question is, are you recommending to hear microservices architecture always? So never monolith or monolith or on certain conditions?
Well, there are two ways. Thanks for the question. It's very interesting, and it falls into our webinar today. There are two ways of going through a digital transformation project. If you recognize or figure out, thanks to the automated analysis tool, that your application is the monolithic application you are going to work on is very well designed, and the amount of effort to be spent is not that much, you can try to go for a microservice architecture. So you do in one step monolithic application to microservices-based architecture, and that's fine. Usually, considering all the use cases we discussed are embraced by the software architect and developers who worked on the monolithic application before you, it's probably usually it's worth to do a two-step modernization. So first of all, you modernize the application in terms of applying the minimal changes to the monolithic application just to make the application work properly and smoothly in a container environment. And then the second step would be moving from that monolithic shape to a microservices architecture, because in that case, you can still reuse, and that's kind of interesting as a use case. So to me, it happened most of the time to not be able to test and verify the changes. So the first thing you want to check is a test framework, to support your work. And if the application is not covered or enriched by a proper test case framework, you shouldn't even start touching the application business logic. Because of course, during the modernization process, you definitely don't want to touch the customer business logic, but that happens sooner or later. And test frameworks, they are the key to certify your work. And usually when you have a very small, a few test cases to certify what you do, it's better to go through the two steps modernization rather than splitting the application. And again, digital transformation projects are not for newbies. You must be very, very experienced. So maybe depending on the expertise of the person involved in a digital transformation project or in the modernization of a single use case, it's better to go, it's probably worth to go through the one-step modernization rather than the two steps. But that really depends on the use case. I hope I gave a proper answer to the question.
Yeah, Jonathan, if you need a little bit more, feel free to put it in the chat. And in the meantime, we actually have a question from Richard. So the question is, when working with customers on moving Monolith to microservices, I found the biggest battle is committing the architect's time to breaking down the application. there are tools for moving a monolith, but are there shortcuts for understanding the strangulation of a monolith?
Well, that's an interesting question as well. So usually, you should always start from the people who have worked on the application before you, and this is not always possible because those people, they are somewhere else, maybe. So usually, the monolithic application targeted by a digital transformation project, their application maintained. It's a few years, so they're already 4 to 5 years, and you would probably not be able to speak to any of those developers. There are some tools, online tools, and tools offered by Red Hat. So we discussed, for example, the migration toolkit for application. You can have a look at another tool that I like, honestly. It's called vfunction. So it's available. It's an online offering. And this is kind of useful when you want to have an automated analysis on how to split applications. In general, you should base your analysis on the business logic, because when you do monolithic applications to microservices, you have to split the business logic. And you can only do that supported by the documentation and the developers or the application manager or the project manager. There is no other way. When you go to microservices, you have to discuss each and every step with the people owning the work, that piece of workload. And then in general, of course, you have to read the source code and figure out what business objects connect to other business objects. And just try to make sure business objects get extended through REST APIs, and then set up and implement an asynchronous or synchronous communication over HTTP rather than over JNI or RMI. That's it.
Thank you, Andrea. Richard, if you need a little bit more on that, feel free to put it in the chat as well. All right, Andrea, those are all the questions for now.
Great. So let's spend the last, well, we've got 20 minutes, so let's spend 15 minutes discussing a bit a kind of use case I'm keen to share with you. So during the last webinar, we discussed how to design a minimal but extensible and scalable OpenShift platform to deploy your workload using standards and reference architectures. Let's see now how to work on an application, and then starting from that architectural blueprint, let's deploy our architecture in terms of scalability, trying to adhere to the microservices architecture, and then keeping an eye on scalability and integration. So it happened to me that's a use case I spent quite a lot of time on, actually. It happened to me to find an application with this kind of structure, okay? Several modules embedded in a final jar, in the final binary, okay? With, I had 2 per common modules. And then I had 4 per business jar, so containing business logic and business, and 2 web applications and 2 test jars. Now you can imagine 2 test jars containing the test cases, automated test cases, embedded into the final binary to be deployed in the application server. So that was quite tough. The big problem here is jars usually, they have this kind of interaction and interdependency. Okay, so you can have usually objects depending on each other, so that's fine. Injections and dependencies are fine. If you are lucky, you can get different kind of jars interacting with each other. So it's pretty easy in that case to split the jars, to remove the dependence in the mailing descriptor or Gradle descriptor, for example, and try to figure out the best way to extend the business object using, again, REST APIs or SOAP APIs, depending on the time and on the use case, and make those APIs consume each other. Lucky us, now the Java Standard and Java Enterprise specification are lots more efficient and extended compared to the time. So this happened 6 years ago to me, actually, or 5 years ago. So back in the days, I had not that many opportunities and features. And so starting from this situation and considering common modules that were included in each and every dependency, and considering these test cases that were supposed to be removed and put actually in other containers to be started and executed on demand, and then expecting that the container with the test framework to be destroyed by the container platform, this stuff could be actually extended properly. And in this case, what I expect to have in terms of new containers is a set of microservices that can cover my business logic. In this case, I can suppose, just to give you an example, a microservice J1 and a microservice J2 that are not communicating directly. Of course, in a container platform, I expect to have services exposed internally and exposed externally through the router. So the way they are supposed to communicate, starting from a platform, a container platform perspective, is having not a router, but a service layer here, service layer, serving the calls between the enterprise applications. And that could be designed exactly in the same way for the web applications. So whether the web application needs to use services exposed by J1 and J2, it has to go through the service layer and discover one of the two layers of the business logic. Now, a standard objection I usually get when I run this kind of discussion or analysis or design is, so they become, all of them are web applications. Yes, of course they are. So that is the smart and quick answer. It depends on what people interacting with you mean by web application. If they believe that the web application is whatever is exposed through HTTP, and in that case, you can't say no. Additionally, you just have to consider that we are not going to expose web pages on J1 and J2. We are just going to expose the business object in terms of available and consumable services on a different protocol. So rather than using RMI, we're going to use simply going to use the REST APIs exposed over HTTP. Exposing RMI is technically possible. Don't do that. And that's kind of the main recommendation I have for you. Now, let's have a look at what we can do considering this approach. And keep in mind that in OpenShift, I'm just going to give you an example based on OpenShift because it's definitely the best platform I could use if I want to migrate to modernize my environment. So what the first thing I would do is to start from my architectural blueprint. Now, in an hypothetical use case, and considering my overall whiteboard represents now the amount of resources I would put, I have available for my modernization project. Sorry. The first thing I would do is to reserve a set of resources for my CI/CD. It's still part of my modernization process. It's not really monolithic to microservices approach, but it's definitely something you need to automate and manage the way you deploy and upgrade your workload. So of course here I want to have my Git repo, for example. Feel free to leave it outside OpenShift, but that's an overall an all-in-one solution that actually works and scale properly. Maybe I want to have my Maven server, so for example Sonatype. Maybe I want to have my Jira application, and of course I need my pipelines. So let's put here Tecton as a native pipeline engine. Starting from here, we discussed last time the need and that it's smart to save resources to modernize my existing integration layer. So to modernize the integration layer, I need to create a cluster of, for example, ActiveMQ instances. ActiveMQ instances that scale independently. And that could be done, for example, through the operators. Available to install, maintain, and upgrade and scale additionally my instances. Having the integration layer here helps with the design at scale, and let me explain why. Now I'm gonna draw just one namespace on OpenShift dedicated to my application. So just imagine this is going to be one of the several layers I dedicate to my application. And of course, I'm going to have here the, let's call it app underscore development, and then the layer app underscore test, and whatever up to application underscore prod, and that's fine. And they are supposed to be almost the same. Of course, the amount of resources dedicated to the dev layer is not the same as the one you dedicate to test and prod, definitely. But the structure, the environment variable are similar. Their value change, but the structure of the environment variable is going to be the same. So in my environment, I'm going to put some microservices here, 1, 2, 3, and 4. Let's say saying J1, J2, J3, and J4. All of them will expose REST APIs instead of making their business objects available through RMI. And of course, I'm going to use my web application 1, and I'm going to deploy, my web application 1 and web application 2. Last but not least, please consider we are not going to deploy services containing microservices or containers or pods containing only the common modules, because in that case, and still adhering to the microservices recommended practices and architecture, they would be embedded into each and every microservice that needs them or depends on them. This means each and every of these microservices here will be placed in a different repo on your Git standard installation and environment. That helps in terms of when you need or when you have to deploy on demand the 2 test services, test 1 and test 2, and definitely start them in order to integrate, to run integration tests if you have available. This is not enough, because we stated already we have several worst cases we can encounter transforming the workload. And what I want to highlight here is, what if we have the need of scaling internally? So the application the modules of your previous monolith could have the need, or it could be smart and efficient to make them communicate asynchronously rather than synchronously. So what I need to do is to put here an AMQ layer within the namespace. This helps in a form of an application. This helps with the communication, internal asynchronous communication, and helps with offloading the data from the main integration layer, and that's quite helpful. Okay, so you don't have 4, just in case all of them need to consume messages layer. You don't have 4 connection pool connected to the main layer, but using the bridge standard from Java messaging, you can offload the main integration layer to the local integration layer and make the messages consumable by the destination here, by the consumers. And you have the opportunity as well to implement an asynchronous communication between business components. Another worst case is embedded caches. Rather than
Andrea, before you get into embedded caches, we had a question asking about the whiteboard. So is this assuming the same cluster for prod and test, or are they just lumped into one whiteboard for simplicity?
Well, in OpenShift, you don't need to have, in OpenShift and in general in Kubernetes-based environments, you don't need to install 3 different environments for dev, test, and prod. No? OpenShift offers this opportunity to isolate namespaces and dedicate all the resources your workload needs for a specific environment. The option of installing or setting up different environments is definitely coupled to not really business restriction, but regulations. For example, if you are a financial company, you are demanded, and let me say in a nice way, forced to have more than one clustered environment. And whatever we discuss when we talk about when we use OpenShift as a platform can be discussed in a logical way. You know, it's not theoretical. It's something practical. But still, when you have an OpenShift environment made up of a control plane, so the master nodes could be 3 or 5 master nodes, and a certain number of worker nodes. At the end of the story, the amount of resources available, generally speaking, in your OpenShift platform is the sum of all the available resources from each and every worker node you have. Of course, then you can apply specific restriction. You can isolate or dedicate specific worker node to do specific stuff or to deploy and host specific services or the integration layer. But it's definitely generic. You don't need to install more than one platform and dedicate the platform to a layer like development, test, and production. Definitely not.
Okay, thank you.
Any more questions?
I have one that's a little bit more related to the 2 questions back. So on the question of like moving from microservices, from Monolith to microservices, the question is, do you suggest targeting greenfield applications first to build the understanding while moving monoliths over to gain some value, or would it be best to break down a monolith to have a direct cost comparison?
Cost comparison is a bit tough to discuss, actually, because it really coupled to the use case. Indeed, it's easy to discuss about return on investment if you adopt specific technologies or framework. Like, for example, now we always talk about Quarkus. Quarkus is probably the fastest, no, not probably, definitely the fastest framework on the market at the moment, not only in the upstream community, right? It's a standard offering by Red Hat, and makes you save 90 to 95% of the resources. And that's definitely true, that's given. I'm using that for my community, the QIoT project community, and I can confirm it's unbelievable. Whatever kind of business logic we are implementing, we definitely have a strong cost reduction. In case of moving monolithic application directly to the platform, yes, it's good if you haven't got enough resources. It's good if you don't feel comfortable with the one-step approach. So you use the two-step approach. Be aware about the fact that you will not be able to apply any kind of scaling here. Because monolithic application, again, means embedded caches, means outdated frameworks. So you have to make sure at least that your frameworks, your workload, your application is based on, is compliant or is certified by or supported by the target container platform. Otherwise, there is no reason why you should work on your monolith just to make it fast.
Okay, awesome. Thank you, Andrea.
Welcome. Well, the last topic was the embedded cache, and then I will on you a question if you want, Jonathan. Most of the time, what I found, having different jars, so I was lucky to have this business logic split into jars, but still all of them, or at least the most of them, were embedding one or even two different cache layers. So the big thing, the smarter thing to do is still to create an application made up of a cluster of, for example, Red Hat data grid instances that help your business logic to delegate data structure, data consistency, and data distribution to a third-party module, which is still compliant and container ready. Just to integrate the answer I gave a few minutes ago, and remark that this whole amount of resources is not hosted by one single worker node. It's hosted by several worker nodes. So let's imagine, for example, we've got a cluster made up of 3 master nodes, so the control plane, and 10 worker nodes. If you scale AMQ to 10 nodes, you will likely get and most probably get 1 instance of your AMQ cluster per worker node. If we scale this to 2, for example, so the local integration layer offloading the main one, you will get 2 instances of different worker nodes. And the same is for the in-memory distributed cache layer. Okay, and when you scale these components of your business logic up to whatever you want, the replicas of this service will be distributed on several worker nodes. No, and again, as we stated previously and during the previous webinar, always keep in mind to make your best to delegate data consistency, scalability, this service discovery to something which is outside, which lives outside of your business logic. Okay. So this is my service, or one of the replicas of this service will interact with one of the replicas of service J2 through the service layer. You don't need, or service J, or one of the replicas of service J1 is not supposed to know where service J2 or one of his replicas is living, in which, or is hosted by which worker nodes. J1 and one of his replicas will ask the service layer provided by OpenShift to figure out where the services are And the routing will be performed and guaranteed by the service layer, not definitely by a connection pool implemented here, no, or configured within the application running the workload for J1. So that's kind of important. Delegate data management, delegate integration, and delegate workload interaction. Is there any question, Jonathan? Because I guess we are over time.
We actually do not have any more questions, Andrea. So yeah. So I think we're fine on that end.
I'm glad. Let me share once more my screen, Jonathan, because I would like to share the survey with our audience quickly.
Yeah, and I put the survey link in the chat, everyone. So, please go to it. This helps us better understand what type of topics you need and what we need to address and get the right people to talk about it. And I'll be sending out the recording and the slides probably 24 to 48 hours from right now. And if you have any questions, feel free to respond to that email, and I'll forward to Andrea. And that's all we have. Andrea, did you have anything else?
No, let me just thank our audience for being here and spending their time with us today. And thanks to you, Jonathan.
Of course. All right, everyone. Well, hope you enjoy the rest of your day, and I hope you got so much value out of this. Till next time.